Okay, first place, when you do this, you want to write out your system first. Okay, now that's all right, because I'd like you to just dive into whatever I'm asking you to do. So you kind of want to do it in an organized fashion. So I'm going to do I write it out like this. -2 times equation 1 added to equation 2. Okay. Now again, our goal, I'm not sure I probably wasn't recording when I did that. Here's a system. I've asked you to eliminate y from 2 equations, then eliminate it from 2 different equations. I suggested that you always use equation 1 because it has a 1 in front of y, which makes it pretty easy to do the elimination. Okay. And then I just wrote down something prematurely. This is what I'm going to want to do. I didn't leave myself room to write it. I'm going to erase my instruction. Guess we don't really need that anymore. And let me do up the smudges. Okay, so my strategy is going to be, I'll use these 2 equations to match up the y's so they go away. I'm going to have a -2 in front of this y, which means I'm going to have to multiply this y by -2, which means I have to multiply the whole equation by -2. So I'm going to say -2 times equation 1. Okay. Now, just to be sure, this is equation 1. This is equation 2. This is equation 3. Okay. -2 times equation 1 is -8x minus 2y plus 12z equals -10. And then equation 2 is 3x plus 2y minus z equals -2. That makes sense? Okay. And you really want to follow this form, because when you get to reducing matrices, which you're going to need to do over the weekend, people have a lot of trouble with that. Because of course not understanding what these instructions mean. Okay. And then the fact that fractions get involved really throws people. So we want to make sure that we do this very systematically. All right. So now we add these 2 equations. We're going to get -5x plus 11z equals -12. Yeah. Do you agree? Anybody get those 2 equations? I mean, anybody get this? Okay. How many of you got this? I'm just checking to see if I'm right. Okay. If that many people got it, then I might be right. All right. Okay, so we have this equation. We're not going to number this equation because it came out of this system. Okay, well, we're going to go back to our numbered equations up here. And we're going to do 3 times equation 1 with equation 3. Not because this 3, here's equation 3, it's got a -3y. To match up the y's, I'm going to have a 3y up here. So we're going to have to multiply this whole equation by 3, and we get 12x plus 3y minus 18z equals 15. And down here we get 5x minus 3y plus 5z equals -7. Now I've labeled this equation we get then when we multiply -2 times equation 1 and add equation 2. So down here, when I add these, it's like I'm going to take 3 times equation 1 added to equation 3. So I get 17x 0y minus 13z equals 8. Okay, so I now have a system of 2 equations. And I'm assuming everybody knows how to solve a system of 2 equations and back substitute. So I'm not going to do that. Okay. But, you know, this equation and this equation, you can multiply this one by 17 and this one by -5, right? And then your x's would match up. Okay. And then you take whatever you get for your y's and your numbers, and you get a solution for z. Okay. And then you substitute that solution back into one of these equations to get x. And then take your z and your x and substitute it back into one of the original equations and solve for y. Right? So we did that on Tuesday. If you weren't here, you do need to check out the video or pick it up from Open Math or wherever. Okay. So that's all I'm going to say about how you solve three equations, 3 unknowns. You eliminate a variable, you get a system of 2 equations, and you solve it. Okay. Everybody did well. I mean, the class as a whole did well with the assignment on solving 2 equations and 2 unknowns. So if you have to review that, okay, but you should be able to then use the scheme. Okay. Reason I don't want to go any further with this because everybody did pretty well with seeing what to do to eliminate y. Okay. With what you get from Open Math and so forth, I think you can fairly easily reduce the task of 3 equations and 3 unknowns down to 2 equations and 2 unknowns. You should know how to do that. If you don't, we can spend some time on it, but you know, really, we need to be spending time, more time on reducing augmented matrices, which I'm going to do next. Okay. Because that is throwing people for a loop. It always does. And the real reason for that is because people don't see the arithmetic. Because you've been enabled to do arithmetic on a calculator without seeing it. Okay, that's what the curriculum does to people. All right. And it's a terrible oversight in the curriculum, and people in education schools aren't going to listen to me, so I don't know why I'm talking to you. But I want you to understand where things are. Okay. I'm going to take and we did this before, so I'm going to do this rather quickly. I'm going to first write out this system of 2 equations that we get here in matrix form. Now, my system of 2 equations is -5x plus 11z equals -12. And 17x minus 13z equals 8. Okay. So if I can solve this system, I'll get an x and a z that I can plug into one of the original equations and solve for y. Okay. Okay, I'm going to write this as an augmented matrix. If you've reviewed the video from last Tuesday, you've seen this, but I'm not going to assume that everybody has. Occasions tend to get out of hand. Certainly did for me. Okay. There we have it. This represents this equation. The numbers here are the coefficients of x, numbers that we multiply by x. Coefficients of z are here. So we understand that this column, first column, is always going to represent coefficients of x. Second column is always going to represent coefficients of z. This dotted line is kind of like an equal sign, and there's the number on the other side. Okay. I'm not going to do this by the type of elimination I used here. I could, I can multiply this equation by 17 and this row by 17, which would be the same as multiplying this equation by 17, right? And I could multiply this row by 5, which would be like multiplying this equation by 5. Okay, I could do that, but that's not what I'm going to do. Instead, I'm going to do, I'm going to rewrite the matrix because I want you to see. Okay. We're going to multiply row 1 . I'm going to divide row 1 by 5. Okay, I'm going to ask you very quickly, just write out these numbers, even if they're not in the matrix, and divide every one of them by 5. What do you get? 30 seconds. Divide this number by 5, this number by 5, this number by 5. You can use fractions. Okay, time's up. I said divide by 5. That's okay. But if you divide it by 5, let's see what I should have told you to do, which is divide by -5. Divide equation 1. This is equation 1. This is equation 2. Divide row 1 by -5. And we get 1, don't we? And then we get -11/5. And we get -12. Well, we get 12/5 because -12 over -5. And then I write down row 2. Here's row 2. 17, -13, 8. Okay. Now next. I'm going to ask a question and we'll talk about it for a minute. What multiple of 1 would I add to 17 if I wanted to get 0? What would I multiply by 1 by so that when I add the result to 17, I get 0? Okay. Okay. Okay, so I want to get 0 here. Okay. I'm not going to tell you why yet. You'll see in a minute. I want to get 0. How am I going to get 0 by adding a multiple of row 1 to row 2? Well, what would I add to 17 to get 0? It'd have to be -17, right? What would I multiply by 1 by? What would I multiply by 1 by? What would I multiply 1 by to get -17? I'd multiply it by -17, right? So what I'm going to do is I'm going to say, okay, I'm going to write down row 1. Right now, I'm not gonna mess with it. I'll mess with it a little bit later. Okay. And then I'm gonna write down row 2 minus 17 times row 1. Now the circle doesn't mean the number 1. I mean, that is the number here. Okay. Circle means the number in row 1. Okay. And the circle 2 means the number in row 2. Well, it should be pretty clear that if I take the number in row 1, which is 1, right? And multiply it by negative 17, I'm going to get negative 17. And then if I add that to the number in row 2, which is 17, I'm going to get 0. That's it. Okay. Now, it doesn't come for free. That was easy. It's easy to see what to do if you know that we want to get 0 here. But now that I've done that to the first number in row 1 and row 2, I got to do it. I got to multiply all of row 1 by negative 17 and add it to the number in row 2. Okay. So what I'm going to get is I'm going to get negative 17 times this, which is negative 187 over 5, and add that to negative 13, which is negative 65 over 5. 187 and 65 is 253, I think. So I get negative 253 over 5. Now, this is where people start getting confused because it's fractions. And people don't really understand the rules. Not everybody really understands the rules for fractions very well at all, because we've always done them on a calculator. Okay. Anyhow, and don't you feel bad about that, but the education system really ought to feel bad about putting you in that situation. Okay, so 12 times 17 is 204, I think. And so it's negative 204 fifths plus 40 fifths, which is negative 164 fifths. Okay. Now, if I did that right, and I did it in my head, so no guarantee. The next thing I'm going to do, and I want you to see this operation, is I'm going to keep row 1. And then I'm going to do negative 5 over 253 times row 2. So what's going to go here? Row 1 of your last matrix. So what are you going to do here? You're going to copy row 1. That's what this tells you to do. Okay. Then you're going to take row 2, but you're going to multiply everything in row 2 by negative 5 over 253. Okay. See if you can do that pretty quickly. Okay. Well, everybody did well. Everybody wrote down 1. Negative 11 over 5. 12 over 5. Okay. So there's your first row. Second row, we got to multiply negative 5 over 253 by row 2. Well, if you're not sure, you better write maybe negative 5 over 253 times 253 over 5. That's negative 253 over 5, right? Okay, now don't say if you got it right. Okay. But what do you get if you multiply negative 5 over 253 by negative 253 over 5? That's 1. Multiplying a fraction by its reciprocal. Okay. Now, about half the class saw it and half the class maybe didn't. Okay. So if you didn't see it, you've got company, but that should be obvious. And that's what I say about overuse of calculators. Oh, if I can't use a calculator, I can't do that. Well, yeah, you can if this is reciprocal of that, right? And also, that means 5 times 253 over 253 times 5. You multiply numerators, you multiply denominators. You have the same numerator as the denominator. That's got to be 1. That's why multiplying a fraction by its reciprocal gives you 1. Because of the rule for multiplication of fractions and the fact that when you divide a number by itself, you get 1. So the point is, well, first of all, what's negative 5 over 253 times 0? Show me with your fingers. Any number times 0 is 0. You're going to get 0 here. And then here you're going to get 1. Right? Now what you get over here is a little bit ugly. It's negative 5 over 253 times negative 164 over 5. Well, you multiply by 5, it's not that hard to multiply by 5. Okay? That's going to be negative 820, and that's going to be what, 1265. Okay. Of course, you could also write this as, it should be negative 5 over 5 times 164 over 253. And negative 5 over 5 is just negative 1. So you don't have to have that big ugly fraction. You got the 5 in common. You could rearrange this, or you could cross lines through it, but I don't like to see people do that because they do it wrong. Then you got 164. Fine if you do it right. If you're not sure you're doing it right, don't do it. Okay, 164 over 253. Okay, this equation says 0x plus 1y equals 164 over 253. There's your solution. That's the y that you need to solve this equation. Okay, that's probably easier to multiply this equation by 17. And of course, you can't see the board, but right there's our original system. We've reduced, we've eliminated a variable, and we're using this matrix method to solve for that variable. Okay, so we now know what, actually it's not y, it's z, isn't it? Because our system had x and z. Okay, so I've been calling it y. I don't have it. Helps if I kind of label this. Here's the coefficient of x, here's the coefficient of y, here's the equal sign, and all that stuff. Okay, so just to remind ourselves, here's x, here's z, I showed y. Here's x, here's z, here's the equal sign. So this stands for 1z equals 164 over 253. Now, how are we going to get x? Well, we could now take this solution and plug it back into one of the 2 equations here and solve for x very easily, right? We're going to do it with a matrix. Okay. So what we're going to do is we're going to add a multiple of this row to this row in order to get a 0 here. So we just have x and 0z equals some number, right? So we're trying to get a 0 here. What multiple of this row would I add to this row to get 0 here? See if you can write it down. Okay. Something times row 2 plus the number in row 1 to give us a 0 here in the z column. What would I multiply by row 2? That would then add to row 1 to give me 0. Okay, here you have it, but not everybody does. Majority don't. what would I multiply by 1? So that when I add it to negative 11/5, I get 0. Because that's what we want. We want to get a 0 here. What's some multiple of this added to this to give us 0? Okay. So what would the multiple be? What number would we multiply by this to get this? Well, what number would we add the negative 11/5 to get 0? Obviously, 11/5, right? So what would I have to multiply 1 by to get 11/5? 11/5, right? So we do 11/5 times row 2 and add it to row 1. What we get then is we get 1, 0, and 11/5 of this added to this. Okay. I'm not going to do that in my head. Okay. But it's 11/5 of 164 over 253 plus 12/5. Okay, that's the number that goes here. We do that arithmetic. And of course, down here, I've got row 2. Okay, there it is. Now, of course, you got to do the arithmetic. And if you go to a calculator to add these two fractions, I'm okay with it. All right. If you go to a calculator to multiply a fraction by its reciprocal, I'm not okay with that. Okay, and you shouldn't be either. So this calculation just goes along. Because like what we're doing, we're taking 11/5 of the number in row 2. Okay. So let's see. Let's take the first column. What's in row 2? 0, right? What's 11/5 times the number in row 2? It's 11/5 times 0 is 0, right? And we add that to the number in row 1. So 0 plus a number in row 1. Well, number in row 1 is 1. We're going to get 1. Okay. 11/5 times this number is 11/5. So 11/5 times the number in row 2 is 11/5. And we add that to the number in row 1, we get 0. And then we do 11/5 of this number added to this number. Well, I just wrote out the calculation. Okay. I could do a decimal approximation with some accuracy, but that's not the actual result. Okay, it's a fraction. That makes sense? So there it is. That's the process. Yeah. So we started with this. We got a 1 here. And we used that 1 to get a 0 here. Then we did a simple multiplication by reciprocal, and we got a 1 here. And then we added 11/5 of this row to this row, and we got this mess. That's our solution. So that illustrates the process of using augmented methods. I'll go over one that we did in the support class. What comes out pretty easily because I made it up so it'd come out without a lot of fractions. Okay. Just again to illustrate the process. You want to see this done, you can go back to the video for the, assuming I can get the videos posted. Right now, I got hacked. Had to change my password. Okay. And now I'm not able to access my downloads file. And the computer I download things on won't accept my password. So I'm hoping I'll be able to get these videos posted today. Try to work through the rest of the obnoxious details. Okay, well, anyhow, I'll get them posted as quickly as I can. Okay, here's a matrix. We want to do this whole process with this matrix. This stands for the equation like 4x plus 12y equals 8. 7x plus 9y equals 2. Since that was our system of equations, this will be our matrix. First thing we want, what do we want? Well, we want to get a 1 here. Now, how do we get a 1 here? Well, divide 4 by 1, we get 1. So divide the whole first row by 4. And that's easy to do because I've made it up so you could do that. You get 12 divided by 4 is 3, 8 divided by 4 is 2. Okay, now we're happy, we got the 1 here. We don't change the second row, we just got the 1. Write down the second row again, and now we want to operate on the second row to get a 0 here. Okay, well, what do we add to 7 to get 0? -7, right? How do we get a -7? We multiply the number in row 1 by -7 and add it. So we take the number in row 1 multiplied by -7 and add that to row 2. Okay. Now we got to do that with every number. So we do -7 times the number in row 1. Now here people get confused. They want to do -7 times this number because they're looking at the second row, but this isn't the number in row 1, is it? Okay, the number in row 1 is 3. So we multiply -7 by 3, we get -21. And then we add that to the number in row 2, which is 9. -21 and 9 gives us -12. Okay. Now, third column, what's the number in row 1? It's 2. This 2, not this 2. Okay. And we multiply that by -7, gives us -14. And we add that to 2, and we get -12. Okay. What do we do next? We want a 1 here. It's easy to get a 1. We want a 0 here and a 1 here. We don't want anything to happen to this 0 because that's where x has been eliminated. We have a 0 here. We want a 0 here because we don't want an x in this equation. Okay, we don't have an x in this equation. So this clearly represents an equation we could easily solve for y. It's -12y equals -12. Bet you know what the solution is. Okay. So we divide this row by -12. Row 2 divided by -12. That negative sign, little messed up. Glitch on the board, I think, or my hand. Okay, anyhow, we get 1, 1. This tells us that y equals 1. There's our solution for y. Now what? We want to get a 0 here. What multiple of this number would we add to this number to get 0? Well, what would we add to this number to get 0? -3, right? What multiple of 1 gives us -3? Well, it's a no-brainer. It's -3. So we do -3 times the second number in the second row added to the first. Okay. So first of all, what's the first number in the second row? 0. What's -3 times 0? Show me with your fingers. It's 0, right? Any number times 0 is 0. So when you got a 0 here, you're always going to get 0. Okay. And then we add that to this, which is going to give us 1. Okay. So there's our 1. And then we do -3 times the number in the second row, which is 1. -3 times 1 is -3. And we add that to the number in the first row, which is 3. And that gives us 0. Okay. Now, what number are we going to multiply by -3 in the third column? Show me with your fingers. Don't see everybody voting. What number are we going to multiply by -3? in the third row. And most of you are saying the wrong thing. It says -3 times the number in row 2. What's the number in row 2? 1. So the question is, what are we going to multiply by -3? It's 1. People get that mixed up, which is why I'm emphasizing it. And it looks like the pattern continues. A lot of people got that mixed up. It's real easy to do. Okay? I've even got to be careful. I know what I'm doing. Okay? So it's -3 times this number added to this number, which gives us -3 plus 2, which is -1. And now, what does this matrix stand for? Row 1 gives us x plus 0y equals -1. Row 2 gives us 0x plus y equals 1. 0x plus 1y equals 1. So x equals -1, y equals 1. That's our solution. If we write out the equation 4x plus 12y equals 8, plug those numbers in, it works. Write out 7x plus 9y equals 2. Again, it works. Okay? That's the process. That's how it works, and that's why it works. Okay? Now, you won't have that assignment until this weekend. Next time, we'll do one with 3 equations and 3 unknowns, just so you really see the process. Okay? But you'll have hands full enough with the 3 equations and 3 unknowns. That'll be due for next class. Okay? Fair enough? All right.